All right, IM2 classes. Today we're talking about completing the square. We're going to be solving quadratic equations by completing the square. Let's get right into it. Before we get into completing the square, what we're going to do is just a little reminder of how to solve an equation like this. So I'm going to put in a line of separation here down the equal sign just to keep track of the different sides of this the equation. To get rid of the square, we are going to square root both sides, right? So this is going to be x. Oh, I don't need that parentheses anymore. I can drop the parentheses because the parentheses were there because the squared and the square root cancel each other out. So I just have x plus 5 is equal to plus or minus the square root of 15. Now, if the square root of 15 simplifies, you're going to do a buddy system on it, but 15 just goes to 3 and 5. So there are no pairs to pull out of that. If you need a reminder of how to do that buddy system, go ahead, check out the video for simplifying radicals. But here, since it's a plus or minus root 15, actually, you know what? I'm going to back up. We're going to leave it like this because this is just going to be easier. If this was a whole number, we'd want to separate out, but I'm just going to leave it like this. So what I'm going to do next is subtract 5 from both sides. So I'm going to get the plus 5 minus 5 cancel out. So I would just left with x is equal to, put the negative 5 first, negative 5 plus or minus root 15. And that's it. We can just leave it like that. So this is good. If you wanted to, you could separate out the plus and minus. So x could be equal to negative 5 plus root 15, or x could be equal to negative 5 minus root 15. So again, just separating out the plus or minus. If you look, one's plus, one's minus. But you can just leave it like that. Doesn't matter. Yeah, so same thing, square root, then add. We're done. We're going to move on. Just a quick reminder, general form of a quadratic equation. We have ax squared plus bx plus c. All right. A is always attached to the x squared, b is always attached to the x, and c is by itself. This is important to remember. We are going to use a, b, and c here. So first thing what we are going to do is we are going to find a C value. So we have A and a B. We're going to find a C value. That's going to make this a perfect square trinomial. That's going to be easy to factor. To find the C value, you're going to do this here. C is equal to B divided by 2 squared. So I'm going to do that off the side here. New blue. So C is equal to B divided by 2. B is negative 36. Over 2 squared. Negative 36 divided by 2 is negative 18 squared. Negative 18 squared is 324. Just want to check my math on that one. 324. So this goes in for C here. So I'm going to add in that 324 right there. This is a perfect square trinomial. So what I'm going to do next is I am going to factor this. So just using an x factor, that ruined my x factors. Okay. I'm going to put in x factor. The 324 goes on top, negative 36 on bottom. Factors of 324 that add to negative 36. This one might be tough, but here's the thing. It's going to be negative 18 and negative 18. So the factors are going to be, I guess it's n minus 18 and n minus 18. And since it's the same factor, we're going to squish those together, and that's going to be n minus 18 squared. So this is going to be the fully factored form. Here's the deal. So this is one of the times I'm going to tell you about a shortcut that we want to do. The reason why we do find the C value this way is because it creates a perfect square trinomial that's always going to factor nice and neat into a square binomial. So the sides of the x factor are always going to be the same thing. And then here, so we don't have to guess and check what are the sides going to be for these. It's always going to be half of that b. Whatever b divided by 2 is, that's what these are going to be on the side. All right, if you can remember that, we can skip all this x factor nonsense and go straight down here. So it's just going to be the variable, in this case, the n plus or minus whatever the half of b is squared. So from here on, we are going to skip the factoring. The whole reason why we're doing this, completing the square, is because it will factor nice and neat, so we don't have to think about it too much. So let's go to the next one, do another thing where we're just going to skip all that factoring. So I still need to find the c value. So it's going to be c is equal to b divided by 2 squared. B divided by 2, that's 17 divided by 2. So I forgot to put the square. It's not 17 divided by 2. 34 divided by 2 is 17. So 17 squared, and I just want to double check that. 17 squared, nope. 289. So this comes out to 289. So that goes in here for our c value at the end. All right. And then to factor this, I'm going to just do the shortcut. All right. It's going to be m plus or minus whatever this value is here. So it's m, this the c, half the b is 17. It's positive 17, so it's going to be m plus 17 squared. Done. All right. So let's look at how this helps us with solving a quadratic. So we're going to have an equation here. What we learned about last time when we factored, we moved everything over to the left side so we could factor. We're not going to do this. The reason why we're going to solve this by completing the square is because they won't factor easily. We'll talk about this more in class, but this is a good method to use if your quadratic doesn't factor. All right, and there's some other parts to it where it's the easiest to use if the b value is even. It's also pretty easy to use. You also want the a value to be 1, positive 1, b even, and then this is what we're going to do. So instead of moving everything to the left and factoring it, step 1, I'm going to move the constants to the right side of the equation. So I have negative 66 here. I'm going to move that over to the right side. So add 66, both sides. So it's going to be p plus 10p plus 66. Minus 66 plus 66 cancels out. Negative 8 plus 66 is a positive 58. All right. So yes. Next thing I'm going to do is I'm going to add a c value to both sides. So plus c to both sides. So whatever you add to one side, you got to add to both. Let me put in a line of separation here. Keep things so we can see the two sides. So if you add something to one side, you got to add to both. So I'm going to find the value of c. So c is half the middle term. It's b divided by 2 squared. B, in this case, is 10. So 10 divided by 2 squared. This is a b, not a 8. Let me fix that. Uh, 10 divided by 2 is 5. Squared is 25. All right, so what I'm going to do is I'm going to change these c's to 25. And so the most common mistake that I see on these is forgetting to add it to this side. All right, make sure you're adding c to both sides. Simplify this side, 58 plus 25, 63 is 83. So just add those together. This side here, that's supposed to be squared there. I'm going to factor the left side using the shortcut. So it's going to be p I'm looking at half of here. So the half of b is 5. It's positive 5, so it's just going to be plus 5 in here. Now it's factored. And now we're going to go back to what we did at the beginning of the video. We are going to solve this using a square root. So I'm going to square root both sides. 83 is not a perfect square. I don't think it even simplifies. And we'll just leave it as square root of 83. So it's going to be p plus 5 is equal to plus or minus square root of 83. Let me clean that up. And then I'm going to subtract 5 from both sides. And I get p is equal to negative 5 plus or minus root 83. Wow. Okay. The board is going nuts. So I know it got scribbled over, but that's all it is. Let's do one more real quick. All right. So again, let me put in a line of separation. Way down. First step, I'm going to add 53 to both sides to get these constants to one side. So when I do that, I get x squared minus 12x minus 53 plus 53 cancels out. 10 plus 53 is 63. Then from here, I'm going to I'm going to add a c value to both sides. Find the c. It's going to be half the middle term. So the middle term is negative 12 divided by 2 squared. Negative 12 divided by 2 is negative 6 squared. Negative 6 squared is positive 36. So I'm going to change these c's to a positive 36. I'm going to factor this left side. So it's going to be x over here, the middle one, negative 6. So it's x minus 6, the parentheses squared, is equal to 63 plus 36 is 99. Square root both sides. 99, that is going to simplify. So I'm going to simplify that radical over on here. So square root of 99, 99 is 3 times 33. 33 is 3 times 11. Those are all primes, so we're done. So if they put it back in the radical, I have a pair of 3s. One goes on the outside, cross those out. And so it is 3 root 11 is what that simplifies to. So square root of 99 is plus or minus 3 root 11. Leave it like that. So then x minus 6. Now I'm going to add 6 to both sides. And so minus 6 plus 6 cancels out. I get x is equal to 6 plus or minus 3 root 11. A lot of people are going to want to make this 9 root 11. You can't add the 6 and 3 together. It's a like terms problem. All right. This has a root 11 attached to the 3, so and the 6 doesn't, so you can't add the 6 and 3. They're not like terms. This is as simplified as it gets, and we are done. We will see you next time when we do the quadratic formula.